Welcome back to another chapter. Chapter 8. Chapter 8, we're going to be splitting into two pieces. The first piece is going to be on rational functions. The second piece is going to be on radical functions. Rational functions is just a big word. It's talking about ratios. We're going to be looking at functions that are fractions. And so that's including like x's in the denominator, things like that. Sounds a lot harder than it is. We'll start off pretty easy, then we'll get into it. The stuff that we learned in chapters 5 and 6 will come back here, and it's going to be important. We'll have to factor and stuff like that. But again, that's not quite today. So today we're going to be looking at variation functions. Our learning targets for today: I can identify and graph direct and inverse variation functions. The two types of variation that we'll be looking at, really. And I can solve problems involving direct, inverse, joint, and combined variation. The direct and inverse are the two types. Joint and combined just really combine these. In fact, joint is combined for all intents and purposes. So these two are just more applications of the two that we'll be looking at. So we keep talking about these direct variation, inverse variation problems. So let's look to see what they actually are. Our two types of variation, we have direct and inverse variation. Direct variation looks like y equals kx. Y equals k times x. That's all it is. And you might be thinking, that looks kind of like a line. Well, you would be right. It's just a line with a y-intercept of 0. That's all direct variation is. It's nothing special. It's a line with a y-intercept of 0. This happens a lot in the world because a lot of times when there's 0, it equals 0. For instance, today I went to Hagen's and I bought 0 pounds of Skittles. How much was I charged? I was charged $0. I bought 0 gallons of gasoline. I was charged $0. And so anytime we have a line that goes to the point 0, 0, it's actually a direct variation type problem. So in our direct variation problem, we have x and y, those are variables. And then we have this k. That k would be the constant ratio, because obviously k stands for constant. Well, all right, maybe it's a c, but it's still y equals kx. That k is just the slope. That's all it is. But we call it the constant ratio because for this problem it'll always be the same. If we divide by x, we get k equals y over x. And so if y divided by x is always going to be the same thing, it's a direct variation problem. This does not happen if it's a line that does not go through 0, 0. So that is important. But again, direct variation. If we wanted to graph this, it's just a line that goes through 0, 0. This is the graph of y equals 2x. We have a slope of 2. Go up 2 over 1. And again, see, there's nothing special with this. It's just a line, has a little different name. It's okay, don't freak out. It'll be fine. Let's look at inverse variation. This is where we're going to get something that's a little bit different. Inverse variation, instead of y equals k times x, we're going to have y equals k divided by x. So here, this is new because x is in the denominator. And we still have k. This time it's called our constant product, because if we multiply the x over, we get k equals x times y. So x times y will always equal the same number. And again, we'll see that in just a second. In fact, we'll see that now. So y equals 6 over x. We're going to graph this. Y equals 6 over x. We could also think of it as x times y equals 6. To graph this, we're going to find some points. So we're going to make a table and find some points. We're just going to graph our points. So what times what equals 6? Yes, Cameron. Yep. 2 and 3. What else times what equals 6? 1 and 6. What else? You might be thinking, well, if 2 times 3 equals 6, doesn't 3 times 2 also equal 6? Oh, and then 6 and 1. Yeah. All right, what else? Oh, I was really hoping he wasn't going to ask what else. Let's see, 1/2 and 12. Yes. And in fact, we can keep going that way. So 1/2 and 12, we could get 24 and a quarter. And then we could switch that. How about when x equals 0, what would y equal? 0 times what equals 6? It's nothing. So x can't equal 0. Okay, that's kind of weird. And then same thing, y can't equal 0. So we can't plug 0 into either of these. So that's interesting. But what else times what equals 6? It's like, 36 and 1/6. Yeah, but let's not get too far. How about -2 and -3? Yeah, if they're both negative, it equals a positive. And so we can get these other numbers that are also both negative. And they'll equal a positive. And so now we can graph this. We have positives and positives, positives. It's going to get closer to 0, but it won't equal 0. And so we're going to get a bunch of points and a bunch of points and connect the dots, and it looks like that. There's 2 pieces to this function. And that's kind of weird. We've never had a function with 2 pieces before. In fact, this type of function is called non-continuous. All the other ones we've had have been continuous. You can always draw them without lifting your pencil. This is non-continuous because there's a gap here. There's a big hole. In fact, it's an asymptote. Remember we had asymptotes with exponential and log functions? This is an asymptote. It's going to get closer and closer and closer to x equals 0, but it'll never equal x equals 0. We also have a horizontal asymptote. It'll get closer and closer and closer to y equals 0, but it'll never equal y equals 0. So we have 2 asymptotes here, and then the functions graph like that. Our inverse variation functions will always look like one of 2 things. It'll always look like this, or if this is a negative number, it would be in quadrants 2 and 4. So that's what it always looks like. There's always going to be the 2 asymptotes there, but we can find it just by plugging in points. So when you graph, plug in points, figure out where it goes, and a lot of times it's easier to plug in points thinking about it as x times y equals a number. Well, what times what equals that number? And so, those are variations. Now, how can we identify what kind of variation it is? We can identify it by finding our constant. For direct variation, we'll have a constant ratio. Y divided by x will always be the same thing. For inverse variation, x times y will always equal the same thing. We'll have a constant product. And then if neither of those happens, then it's neither, and we can't tell what it is. And so, if we have a few problems here, looking at this, we don't have to do both of these. We can probably look at it and cancel one of these out. So like the division. Let's see, y divided by x. 2 over 6, 3 over 4. Are those going to be equal? No, those aren't going to be equal. So let's try product. X times y. It's going to be 2 times 6 is 12, 3 times 4 is 12, 1 times 12 is 12. Hey, look, those are all the same. We have a constant product, and so we have inverse variation. Looking at this one, if we want to multiply these, 30 times 24 is not going to be equal to 4 times 5. So let's try the direct let's try it, see if it's direct variation, see if we can find a ratio. We'll have 30 over 24, 5 over 4, 15 over 12. And then we can reduce these. 30 and 24 can be divided by 6. 5 fourths is fine. 5 over 12 can be divided by 3. And those all turn into 5 over 4. So here we have a constant ratio, which means that this one's direct variation. And then over here, if we divide, we have 3 divided by 2, 6 divided by 5, 4 divided by 9. That's not going to be the same. We can multiply. 2 times 3 is 6. 6 times 5 is not 6. So that's not going to be the same. And so this one's just neither. It doesn't work for either of them. And so we can identify just by either adding or multiplying the x and y's together and seeing what we get. Looking at our problems, we're going to be solving problems. We're going to be writing variation deals from word problems. And these always set up exactly the same. For direct variation, we're always going to get a sentence that says y varies directly as x. And then it'll give us some extra information. This means y equals k times x. It could be peanuts varies directly as elephants. Peanuts equals k times elephants. Bananas varies directly as peanut butter. Bananas equals k times peanut butter. Ice cream varies directly as clowns. Ice cream equals k times clowns. It just goes right in order like that. The trick, don't forget the k. That's the biggest mistake for both of these. So we get y varies directly as x, which means y equals k times x, and y equals 6 when x equals 3. So we're going to use that information to find k. Plug it in. You can plug it into this part of the equation. It's already solved for k. So k equals 6 over 3, which is 2. Then just put that into the equation. Y equals 2x. Done. So looking at another one, y varies directly as x, and y equals 45 when x equals negative 5. So y varies directly as x says we have direct variation. It's going to look like this. So k equals y over x. So plug in to find k. 45 divided by negative 5 is negative 9. And just plug this into the equation. Y equals negative 9x. You may be graphing these. That's fine. It's just a line. Slope 2 goes through 0, 0. Slope negative 9 goes through 0, 0. Inverse variation problems are the same, except we'll say y varies inversely as x. It's y equals k divided by x. And same thing, doesn't matter what the variables are. We could have snow varies inversely as temperature. Snow equals k over temperature. And y equals 2 and x equals 7. So, same deal. K equals x times y. So k equals 2 times 7. So k equals 14. Plug it in. Y equals 14 over x. You can graph this. Just make a table with a few points on it. And you can plot your points. Y varies inversely as x. Means we have this. And y equals 1/2 when x equals negative 10. Plug them in. K equals 1/2 times negative 10, which is negative 5. So y equals negative 5 over x. That will graph the same, except that it'll be in quadrants 2 and 4 instead of the 1 and 3 where it's positive. And then we have another type of variation. This is where we're getting to the joint variation. A joint variation is going to be just two things working together in direct fashion. So if we have something like y varies jointly as x and z, it just means y equals k times x times z. We just have a couple things affecting it there. And then the next one would be kind of combined variation, but I consider it joint variation. Y varies jointly as x and z, and inversely as w. So jointly is on top, inversely is on bottom, and don't forget the k. Y equals kxz over w. And so you can set up any equation just kind of like that. Anytime it has jointly or directly, it's on top. Anytime it has inversely, it's on the bottom, and then don't forget the k, which is always on top. And so, this is how we can set up equations. Now, how can we solve some problems? Well, wavelength lambda, it's a Greek letter, lambda, of a wave of a certain frequency varies directly as the velocity of the wave. So we have lambda varies directly as velocity. Lambda equals k times velocity. Then it tells us something that we know. Plug this in to find k. We know that lambda equals 60 feet, velocity equals 15 feet per second. So we have 60 equals k times 15. Divide by 15 to get k equals 4. We can plug that into our equation. Lambda equals 4 times velocity. And then, so it gives us two pieces to find k. Now it'll give us another piece, and we just have to find the other one. So here it gives us velocity, find lambda. So plug in 3. It could also give us lambda and have us find velocity, where we divide by 4. But here it gives us velocity is 3. So lambda is 4 times 3, which is 12 feet. So the wavelength is 12 feet. And they're all going to set up like this. If we look at a inverse one, time t it takes for a salesman to drive certain distance d varies inversely as the average speed r. That would be time t varies inversely as the average speed r. So t equals k over r. Then we have a point here. We have a time and a rate. So we have 4.75 and 60. So we can set that up. Multiply by 60 to get k equals 285. Plug k back into the equation. Time equals 285 over r. And then again, here it could give us t or r, and we can find the other one. Here it gives us r, 50, and we just have to divide. 285 divided by 50 is 5.7 hours. And so we can solve any of the problems like that. Same thing goes with the joint variation problems. If we have 3 variables, it'll give us 3 variables. We can find k, then it'll give us 2 of them and ask us to find the third one. And so it's all the same thing. So this one's kind of interesting because we have x's in the denominator and things like that, but all the questions really end up being pretty much the same. So don't forget to make a comment in the classroom, and I will see you in class ready to do an activity and answer some of these problems and get started on your homework. I will see you then.